So here's what we wanted to happen with the first mini challenge, the door hinge. We wanted you to understand your own grasp of dimensions and units, specifically in this case millimeters. Like, what does somebody mean when they say this and this is 10 millimeters long or 50 millimeters? Do you ever mentally reference when you hear a dimension like that with something that you know well? Or are you totally lost when somebody gives you a dimension, a length of something, and you have no idea if this is as long as your hand or as long as your house? So go ahead and measure your finger now just to see how good your guess about its width was. And then measure the hinge that you were looking at. And you can see, was it close? Was it in the same ballpark? By the way, when somebody refers to the ballpark thing, they usually mean, did it end up in the correct order of magnitude, or was it off by more than that? If you're in the correct order of magnitude, that's not too bad. So now let's have a look at what I came up with here. This part was the first one that I drew, and based on me guessing that my pinky might be 12 millimeters wide and the hinge was 5.5 pinkies tall, I wrote down 66 millimeters total. I came up with the width the same way, so ended up with 30 millimeters. And then I noticed that there's symmetry in these hinges. Symmetry always comes in handy because it means I have to measure fewer items simply because they're mirrored within the part, and thus on the other side of the mirror line or symmetry line, the dimensions are just the same. For these holes, my guess was that they are half a pinky away from the edge and pretty much in the middle of the width of that thing. For the hole in the middle, right on that symmetry line, I guessed that half a finger was also the distance from the edge for that one. I didn't write down a diameter for the holes since I couldn't exactly see the details. There are some screws there, but they are flush with the surface, and that means there's something else going on here. The pin that holds the parts together in the middle looks like a nail, but I didn't add dimensions in this stage. I don't remember why. And the other half of the hinge is just kind of a mirror image of the first part. But then I realized just after starting the sketch and drawing a wrong bit here that the way the parts intermesh, there's only 2 of these cylindrical bits on this part instead of 3 on the other side. And I noticed that these 5 cylindrical parts with holes are all the same length. Next, I redid my drawing on a second piece of paper. The main thing I tried to make sure was that I didn't make any more mistakes. No extra lines, and I tried my best to represent the 5 equally long cylindrical parts. And for the first time, I'm adding a guess dimension for the diameter of these parts. The inner one I didn't. I drew it in a way that makes it appear that the inner diameter might be half of what the outer one is. So in the end, this is my final product for the paper sketch. Next, I have a screen recording of how I made a CAD model of this. I'm showing it in real time for those of you who are interested, and this part of the video is about 18 minutes long. If you know how to do this but want to see the conclusion, just skip it and jump to 21 minutes and 30 seconds. When I CADed this up, I did not use many of the tricks that these programs offer. For example, one can make copies of parts, mirror them, and add or remove features. Or one can do a Boolean operation and subtract one part from another. I'm doing this whole thing in a very pedestrian way. Just keep that in mind. If you know CAD but want to see a little bit of the things that I was doing, there are some interesting bits at 9 minutes and 30 seconds, for example, where I make a good use of dotted auxiliary lines, called construction lines in CAD, to divide the overall height of the hinge into 5 equal parts without having to enter an actual length. Have a look. And at 13 minutes and 55 seconds, you can see how I used the first part to generate the details on the second one. This would have been done more efficiently by a Boolean operation, but there you go, this is what I did. Starting at 17 minutes and 26 seconds, I'm making an assembly from the parts in my part studio, and that might be the most interesting sequence for you to see because it shows just how simple it is to make an assembly in CAD that moves and operates just like the actual mechanism does in reality. In the end, it turned out, I guess, my finger a bit too thin. I don't have a 12 millimeter pinky, it's actually more like 17 millimeters. As you can see, the real hinge is 89 millimeters tall and 40 wide, but the round bits seem to be around 10 millimeters. Not too bad. There's one detail that I didn't catch. The holes have a broken edge. This is called countersinking, and it is done with this tool on a drill press after making the actual holes. It is done to allow so-called flat head screws to sink into the part and to be flush with the surface. In the case of the hinge, this is needed to make sure that this hinge can fully close without running into the heads of the screws. In CAD, this can be done with an operation called chamfer, you see here. Anyways, this was it, and I hope there was something in here for you. As always, I'm happy to hear your feedback.